All right, so today we are doing triangles. This is all going to be a refresher, basically. You guys know this stuff. And we're just going to talk about the angles of triangles, which you guys already know. There's 180 degrees. We're going to talk about equilateral triangles and isosceles triangles. So, how are the angles how are the angles of the triangles related? And what kind of things can we determine about side lengths and angle measures? So let's get started. These won't take us very long to get through. Like I said, this is stuff you guys already know. So if I ask you to classify a triangle based on its angles, you're either going to tell me it's a right triangle because there's one right angle. You will tell me it's obtuse because there's one obtuse angle. You will tell me it's acute because there are three acute angles. Or you'll tell me it's equal angular because there are three congruent angles. Or I may ask you to tell me what kind of triangle it is based on its sides. So we all know that if there are no sides congruent, then it's scalene. If there are two sides congruent, it's isosceles. And if all three, it's equilateral. So let's look at some practice problems. So if I ask you to tell me what kind of triangle this was based on its sides, since all three sides are 18, that makes this equilateral. So this would be equilateral. And since all the angles are all 60, that also makes it equiangular. And number two, there are three different sides. So this one is scalene. And since there's that one obtuse angle, then this is an obtuse triangle. In this one, I have two sides that are congruent, so that makes it isosceles. And since there is one right angle, that makes it a right triangle. And if I wanted you to draw an obtuse isosceles triangle, then you would draw an angle that's more than one. So let's say this is 110 degrees. And then we'll pretend that that's beautiful and perfect. So two congruent sides make it isosceles. This angle is greater than 90. That makes it obtuse. All right. Now this next part, if I wanted you to classify this triangle, I would need you to classify it by its sides. But to classify it by its sides, you need to know how long each side is. So how do you determine the length of something when it's on a grid? Well, if you will recall, if I wanted to know the length of this side here, I could use the distance formula and use the 2 points. Or I could create those little right triangles so that that becomes the hypotenuse. This has a side of 1, this has a side of 2. So now I can do the Pythagorean theorem and get the hypotenuse. So 1 squared plus 2 squared, take the square root. So that would be 1 plus 4, which would be the square root of 5. And I'm just going to leave it like that. And remember, a squared plus b squared equals c squared, which will tell me that c is a squared plus b squared, take the square root. So that's what we're doing. All right, if I wanted to know the length of this side here, then I would draw the right triangle coming this way. This has a side of 1, and this is 1, 2, 3, 4, 5, 6, 7. So this has a side of 7. So this one is PQ, so this would be 1 squared plus 7 squared. Take the square root. 1 plus 49 is 50, so the square root of 50. And I'm not worried about finding the values because I just want to know if the square roots are going to be the same. All right, so now this is the last one. I want to know this side, so I'm going to create this right triangle. This has a side of 3. 1, 2, 3, 4, 5, 6. So now this one is 3 squared plus 6 squared. So that would be 9 plus 36, which is 45. So since all three sides are different, it is scaling. And I want to know if there's a right angle. Well, remember for us to determine if sides have a right angle, we need to know if they're perpendicular. So since I know all the slopes, because that's pretty much what we used to create these right triangles, I want to check the slope between all three. So let's do the slope of PO. So the slope of PO would be this one here. So that's go down to over 1. So down to over 1. And let me close that out. And then if I want to find the slope of PQ, so the slope of PQ, so that's rise 1, go over 7, rise 1, go over 7. So there's definitely not a right angle there. And then the slope of QO, so the slope of QO, down 3, backwards 6, down 3, backwards 6. 2 negatives make a positive, and it reduces to 1/2. And these two, this is definitely not a right angle. Oops, this one here. So I need to compare this one, which is -2 over 1, to this one, which is +1 over 2. Since these two are negative reciprocals, this is a scaling right triangle. All right. What about the exterior angles? Okay, so we've talked about the interior angles, so let's talk about the exterior. So in the exterior, so actually let's still talk about interior angles. I'm sorry, I got ahead of myself. I know that if I add the three angles together, so this angle plus this angle plus this angle, they add up to 180. So 40 and 30, so 40 plus 30 is 70. And I know they have to add up to, with this one, it has to add up to 180. So 180 minus 70 is 110 degrees. So angle 1 is 110 degrees. Same thing over here. I have one angle that's 90. I have one angle that's 2x. And I have one angle that's x minus 6. They still have to add up to 180, even though it's not numbers. So I see that I have 90 minus 6, which is 84. And then I've got 2x plus x, which is 3x. So subtract 84 from both sides, and you get 96. And divide by 3, and you get that x is 32. So if x is 32, this is 2 times 32, which is 64. And this one is 32 minus 6, which is 26. And if you were to add 64 plus 26, you get 90 degrees. That is because the acute angles of a right triangle are complementary. So that means they add up to 90. So this angle plus this angle add up to 90. Okay. Sometimes they'll give you a word problem and no picture, which means you're going to have to draw the picture. So right off the bat, it says in a right triangle. So I'm going to draw a right triangle. So since I have a right triangle now, I know that this is my right angle. It says the measure of one acute angle is twice the sum of the measure of the other acute angle in 30. Well, I don't even know what the other angle is, so I'm going to call the other angle x. So this one up here is twice the sum of the other angle in 30. This corollary tells me that these two angles are supposed to add up to 90. So I'm just going to add this angle to this one. So 2x plus 30 plus x equals 90. 2x plus 60 plus x equals 90. 3x plus 60 equals 90. 3x equals 30, and x is 10. So this angle is 10 degrees. This one is 2 times 10 plus 30, which is 2 times 40, which is 80 degrees. So my angles are 10 and 80, which do equal 90 degrees when I add them together. Now let's talk about exterior. All right, so this is the exterior angle. The theorem says that if you add the two angles that are not touching this one, so this would be my adjacent angle. So if I add these two together, then it gives me the outside angle. So for example, this is my exterior angle. This one is adjacent. So add these two together, and it gives you angle 1. So angle 1 is 53 plus 53. So angle 1 is 106. So 106 degrees. Same thing here. If I add these two together, it equals what's on the outside. So 70 plus x is equal to 2x minus 5. So subtract x from both sides. 70 equals x minus 5. Add 5 to both sides. And I get that x is 75. So that means this angle is 75 degrees. So this one, well, I can do it one of two ways. I know that this angle is the sum of these two. So 70 plus 75 equals the exterior angle. So 145 is the exterior angle. So if x is 75, JKM, which is the exterior, is 145. So bonus material, I know that this angle plus this one is a linear pair. So that means they have to add to 180. So if I subtract the exterior, I get that this angle here is 35 degrees. All right, the last part, and this is our isosceles triangles, which you already know these guys too. So in an isosceles triangle, it has exactly two congruent sides. So these two have the tick marks. So AB is congruent to AC. And these are your legs. So these are your legs. The vertex angle is formed by the legs. So this would be your vertex. So angle A is your vertex. The third side is known as your base. So BC would be the base. And the base angles are the two angles at the base, and they're congruent. So angle B and angle C. All right. There's a theorem that says that if two sides are congruent, then the two angles are. And if thus said the converse states that if two angles are congruent, then two sides are. So since these two sides are congruent, these two angles are congruent. And in this picture, if these two angles are congruent, well, then those two sides are congruent. So no matter if I give you sides or angles, if there's two that match, then it's isosceles. Guaranteed every time. So in this one, we're going to look at angle B. It's congruent to angle C because they have the same tick marks. And since B and C are congruent, I know this side is congruent to this side. So I know that AB and AC are congruent. The vertex angle, well, since these two are my base angles, then the vertex is angle A. And since these two sides are congruent, then 3 times x plus 2 equals 24. So 3x plus 6. So 3x equals 18. So x is 6. So if this one's 24, I know this side is 24. And to find the measures of these two angles, well, remember that all three angles have to add up to 180, right? So if I have 180 minus the 90-degree angle, there's 90 degrees left over, and I have to share it between two because they're congruent. So that makes each one of them 45 degrees. So now, if I wanted, I could also find BC. So let's go ahead and find BC. Because it's a right triangle, I can do Pythagorean theorem. So 24 squared plus 24 squared, take the square root. So 576 plus 576, take the square root. Let's see, 576 plus 576 is 1152. So the square root of 1152. And if I take the square root of 1152, I get 33.9. So 33.9 would be the length of BC. And that is how you do isosceles triangles. So knowing that now, when you look over here, you should see two triangles. You see an equal angular, which means equilateral. And then you see an isosceles because these two angles are the same. So these two sides are the same. Well, if this one is 4, then this one's 4, and this one's 4, and this one's 4. So that means y is 4. Well, since these two are equal, x plus 1 equals 4, so x is 3. So sometimes it's just super easy. You just have to pay attention to the markings in your picture. So I will see you guys next time, and we will cover any questions that you have.